Saxon Advanced Mathematics, Lesson 1. Welcome, ladies, to a new year, a new math year. There are 3 of us studying together. I think you guys all know each other. We've got Jayla and we've got Vivian and Laura. Jayla has studied with me in the past. Laura and Vivian, you guys have worked together and with your mom on Saxon, but you're working with me for the first time this year. So here we are all together. There may be some other strangers from YouTube joining us, but I know for sure that the 3 of us are together. So welcome to distance learning, and let's dive in. John definitely has rigorous expectations for students who are beginning this book. He jumps in with a big, heavy dose of review in lesson 1, but he also expects you to remember a whole bunch of stuff from the past that may or may not be easily accessible in your brain. So what I want to do is I want to quickly review for you the material that he shares from lesson 1, but I want to spend more of our time working through a handful of the actual homework problems so that you remember how to do these, because he doesn't have examples in the lesson for all of the different problems that he asks you to do. It's a bit of an unfair gig he's got going. Okay, geometry review. We remember that a series of points make up a line or a curve. Only one line can be drawn through 2 designated points. We can talk about lines and segments by using letters and drawing a little picture of the shape we mean. These are all lines. There are all ways to describe this line. This is a segment, and these are ways to designate the segment. Blah, 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 blah. Similar, we've got rays. We've got intersecting lines that form vertical angles. Vertical angles are equal to each other, right? These 2 angles are equal to each other. A plane is a 2-dimensional, I think of it as like a pane of glass that's out of a window. Pane and plane go together in my brain. It's indescribably thin, but it has length and width, and we can have lines that lie within the plane. Now, sometimes you have a line that goes out of the plane, but we're not going to spend too much time talking about those. Those are called skew lines. They're not in the same plane. We're going to talk about intersecting lines, and again, they form vertical angles. We're going to talk about parallel lines, and also perpendicular. Perpendicular, he doesn't have a picture of them here, but they make a plus sign, right? Make perfect right angles. So that brings us to angles. Angles happen when 2 lines intersect. They also happen when 2 rays leave from the same point. We'll get into this more as we delve into the trig world, but there's an initial side and there's a terminal side. That implies a certain amount of movement. Here are ways we can designate the angle using letters. This you've probably seen multiple times. A straight angle is 180 degrees. A right angle is 90. An acute angle is less than 90. Obtuse is greater than. Okay, so those are all words that describe the size and shape of angles. Then we have the concept of supplementary angles, where the 2 add up to make 180, or we have complementary angles that add up to 90 degrees. And we already talked about this, vertical angles. These concepts are really popular in a math program because we can use geometry and tie it into algebra really nicely. Next topic, betweenness, right? One point is said to be between 2 other points only if they lie on the same line. X we don't say is between A and C, but we say that C is between A and B. tick marks indicate that two things are the same. So if we see two angles that are marked like that with those tick marks, that means they're the same size angle. And these are the same size segment, all right? This is, I don't even want to get into all that. Let's look at the triangles. A right triangle, an acute triangle, obtuse, equiangular, all the angles are the same. What is this isogonic? I think that means two angles are the same. And then we can also talk about the sides. Equilateral, isosceles, scaling. This is referencing the lengths of the sides. The other names talked about the size of the angles. Transversals are cool because we can make a lot of interesting problems out of them. Remember, it's this idea that if we take parallel lines and then karate chop a line through them, it sets up these pairs of angles, larger and smaller, that will all be the same size. Here we have them with numbers. And then we can do interesting algebra problems with them. Remember that if we make the transversal straight, it's still a transversal. It's just kind of boring because everything's 90 degrees. So we don't usually play with that. We usually drop those transversals in at an angle. Here they're referring to them as interior angles and exterior. That's not earth-shattering. He shows just lots of different ways we can look at transversals, but the basic idea is that you're creating two sizes of angle and they play out over and over again in the overall pattern of a transversal. Here, what we have is instead of two parallel lines, we have three, and then we have a transversal cutting through. And a cool thing is that these are proportional. The segments of the different transversals are going to be proportional to each other. So here's the way John sets that up. So what we've got here is we've got these two segments quantified, and this one is not. So John sets up a proportion to solve for the missing side. I would set it up as 3/4 equals x over 6. John sets it up differently. When we get to the problems, I'll show you those. Areas. Here are some different formulas. What I recommend you do is on the inside cover of your homework book, or on a separate sheet of paper if that's a better way for you. I recommend that you write down all of your formulas. Here's a great place to start. Area of a rectangle is length times width. Area of a triangle is 1/2 base times height. Here's another version of a triangle that just reminds you that the height is not necessarily the side, it's the straight line down from the highest point in the triangle. I'll talk to you about spiders eventually with this, and same here. The spider climbs up to the highest part of the triangle and drops his first web line straight down. That's how I remember. Circumference, when we get to a circle, we talk about the circumference and the area. Here are formulas for that. If we're talking about the sector of a circle, here we are. Okay, so this is a circle. Here's an angle measured from the center of the circle. We can measure it as an arc or as an angle. It's 18 degrees either way. If we want to find the area of this tiny sector or the length of this little bit of arc, we create an adjusting fraction. We take the size of the angle or the arc, because they'll be the same. In this case, it's 18, and we create what I call an adjusting fraction by putting that over 360. And then we multiply that against either the overall area or the overall length calculation. This would be the circumference. And use that to adjust down to just the piece that we're talking about. There's an example for this, so let me do that, and then you'll know what I'm talking about. So this is example 1.1. And let's take a look at it. It says the measure of the central angle of the unshaded sector is 126. Okay, so let me draw a picture for you of what's in the book. Sorry, you guys, that was a really quick and dirty review. I don't usually like to do it. That's not the way I normally teach. But it's a great way to cover a whole lot of moderately useful information in a very quick time. And now we have more time to do the rest of our lesson together. Okay, so here's an actual problem. I'll read it again. It says the measure of the central angle of the unshaded sector, is 126 degrees. That's what this is telling us. The radius of the circle is 2 square root of 5 meters. Well, that's just mean, isn't it? What a mess. Find the area of the shaded region of the circle. Okay, I'm going to write that down. In your homework, I wouldn't. I'm just writing it down so you know. Find area of shaded region. Okay, we know how to find the area of a whole circle. Area equals pi r squared, right? So we can square that. That's not a big deal. And we'll multiply it by 3.14, and that will give us the area of the whole circle. But we don't want the area of the whole circle. We want the area of the shaded region. So what we have to do is we have to create an adjusting fraction. And what that does is it basically whittles down from the whole circle to the part we're interested in. Now, we're not interested in the 126. We're interested in the other part. So the first thing we want to do is say, what's the size of the other part that we actually care about? It's 360 minus 126, right? 360 is the whole circle. 5. 234 degrees is the part we care about. So we're going to adjust our calculations to take into account this proportion of the circle. This is the measurement of what we like. 234. And we put that over 360 because that's the whole circle. So that's our adjusting fraction. Can we reduce it? Well, let's see. It would be nice if 3 went into it, because I know 3 goes into 360. How do we know if 3 goes into 234? I see you all eagerly raising your hands and wanting me to acknowledge you, and I can't. But what we do to see if a number is divisible by 3 is we simply add the digits. 2 plus 3 plus 4. That is 5 plus 4 is 9. 3 goes into 9, so 3 should go into both of those numbers. So I'm going to divide top and bottom by 3. That's 120. I can do that in my head. Let's just do this by hand so that I don't confuse you. I'm taking 234 and dividing by 3. 3 into 2 doesn't go. 3 into 23, 7 times. And that's 8. Okay, don't even have to finish it. So 78 out of 120. Okay, that's better, but let's see if we can reduce it some more. Could I do 4 into both of these? 4 goes into that 30 times, but it's not going to come out even in this. So because 80, 4 times 20 would be 80, and this is only 2 less than 80, so I know that's not going to work. So I'm just going to divide both by 2. This would be 35, be 39. I did 70 and half is 35, and then 8 and half is 4. 35 and 4 is 39. That's how my brain did it. And then this is 60. Well, I see that 3 is going to go into this again. So I'm doing this the hard way, but I'm whittling this fraction down, right? 39 over 60. Maybe you saw a faster way. But now I'm finally to a place where I can stop, right? Because 13 is prime, so I know I'm not going to be able to break that down anymore. So all of this work has just been in reducing my adjusting fraction to its lowest terms. Now I'm ready to go back here and say that the area of the sector equals 13 over 20 times 3.14 times this squared. Okay, so let's go down here and remember how to do that. 2 times, no, I didn't write that right. It's 2 square root of 5 times 2 square root of 5, right? Because I'm squaring it. That's my formula. So I'm multiplying it by itself. Vivian and Laura, I have this whole thing of where numbers like this are wolves and pigs. This is the 3 little pig hiding in his house, and this is the wolf. So when I'm multiplying this, I multiply wolves against wolves, pigs against pigs. So I get 4 times the square root of 25, right? I multiply the pigs together and the wolves together. Square root of 25 is 5. So that equals 4 times 5, and that equals 20. So then this goes here for 20, right? So 20 is 2 times the square root of 5 squared. Now, happy freaking days, you guys, because these cancel. Oh my gosh, are you happy? I'm happy. This is equal to pi. When I glance at the answer, I see that John gives us the answer with pi still in the calculation. He did not multiply it through by 3.14. That is a great time when you get to this point and you say, I wonder if John shows the answer as a number or if he leaves pi in its place. So I glance back at the answer in the book and I say, oh, he left it as pi in this case, so I will too. And I am fine with that. Leave your answer in whatever form John gives so that it's easier for you to compare. So I'm going to say that the area of the sector is equal to 13 pi, and then it's meters, and it's area, so it's squared. 13 pi meters squared, and that is the correct answer. Okay? I did a lot of hand calculations and reducing in this thing, but the calculation itself was pretty straightforward. It's all about that adjusting fraction. All right? That is the only example that we have for all of that content that we just reviewed. But I want to show you one more thing. John introduces a type of problem called a concept review problem. These are kind of brain-twisting, mind-bending ways of looking at mathematical concepts. And they used to be used on SAT and ACT tests to check students' mathematical reasoning. No one uses them anymore, okay? So we're not going to cover this style of problem. You can look at it if you want. They're really confusing. They take simple ideas and make them really hard, and I'm not a fan of that. So we're going to skip the concept review problems. The other examples are all examples of concept review problems, so don't do them. They have friendly looking diagrams, but it's just all in the way that the question is worded and the answers are offered that is super mind-bendy, and I don't want you to get confused by it. So what that means is that you'll see at the end, now we're in the problem set, right? This is the homework. At the end, the last couple problems will be clearly labeled as concept review problems. Don't do them. Just ignore them, okay? And remember, that's old-fashioned SAT stuff. We don't do that anymore. Goodbye. All right? So that takes us through all of lesson 1. Again, we skimmed most of it because it was just conceptual review. We're skipping these concept review problems. And what I'm going to do now is run through the first 5 homework problems to help you get a handle on, get your brain back in gear, okay? All of these require you to remember what happened last year. So you may need to rely on the solutions manual to help you remember how to set it up. Some of these I approach differently than John does. So Jayla, flag me and I will help you remember how we did it. But I want to work through these first 5 as the rest of our lesson 1 presentation, okay? So I'm helping you with your homework. What I hope you'll do is work these problems without looking at your notes so that you actually see if you remember. Okay, so this is problem set 1. And this is problem 1. Grab your book and look. Okay, find the measure of angle A. Oh my gosh, you guys, listen to this. It's so confusing. Find the measure of angle A if the complement of A is 150 degrees greater than the supplement of angle A. Okay? Yikes. So it's a comparison thing. We're going to have to write an equation and we're going to have to solve it. But then John gives us a really nice hint. Remember that the complement of angle A has a measure of 90 degrees minus A. Okay? So let me write that down so you can see it. Complement of A equals 90 minus A. Ah, that gives me a mathematical expression I can substitute in for words. And the supplement of A would be 180 minus A. Aha, okay. That makes it a lot easier to translate words to equations. All right, here I go. Let's try it again. Find the measure of A if 5 times the complement of A, so 5 times the complement of A is greater than the supplement of A. Now, notice I have not written an equation, I've written an inequality because one side is greater than the other. John gives me a number that's going to balance this out so I can write a proper equation, but I always write an inequality first so that I can match my numbers to the words better, and then it helps me figure out how to use that number to balance it. This is not the way John shows it. This is the way I think it is much easier on your brain. So Vivian and Laura, welcome to my world. Okay, let me read it again. The complement, 5 times the complement of angle A, that's the complement of angle A, that's 5 times, is greater than the supplement of angle A, and that's that. Okay, great. Now I'm ready to balance. And I remember that this sign tells me that this side is greater than, this side is lesser than. And it tells me that 150, it's 150 degrees greater. So I have 2 options. I can either add 150 to the small side, or I can subtract 150 from the big side. What I usually like to do is write it over here so that I can just change this. I have more room to work. So this is the smaller side, so I'm going to add the 150, and then I'm going to change that to an equal sign. That's how I go from inequality to equality. Now I have a solvable equation. I'm going to distribute the 5. 450 minus 5a equals, and I'm going to combine these 2 like terms. That's 330 minus a. Okay? Now I'm swimming fish. Vivian and Laura, when my 7th grade algebra teacher, Mr. Lacrone, back in 1971 or 2 or some crazy thing like that, he taught me to think of these kinds of equations as schools of fish. We have our plain number fish and we have our lettered fish. And what we want to do is get them to swim back to be with their like kinds. So we're going to swim the plain number fish together and we're going to swim the A fish together. The question is which way to go. It doesn't matter, but we like to, it's easier if we have positive numbers, right? So let's add 5a to both sides. And at the same time, we'll swim this plain number fish over here. These cancel, and we get 120 equals 4a. It is super important to me that we are all on the same page of how we show our work. I'm not sure exactly what you guys were doing in the past, Rice Ladies, but please use this formatting. If you have something else that you do that you really, really love, tell me and we'll talk about it and find a meeting of the minds. But this is a super clear and very classic algebraic presentation that I want you to copy. And definitely show your work. Okay, divide by 4. Again, you can do this in your head, but I want you to show your work. That cancels, and we get A equals 30 degrees. Let me double check my answer. Jumping into the solutions manual. A equals 30 degrees. That's correct. Okay. Yay. Problem 2. Well, I think problem 2 is actually really similar. Yes. Problem 2 is very similar. I'll do 3. 2 can be a surprise for you. Find an angle such that 4 times its complement equals 200. Well, that one's actually really similar too. So 4 times, we'll let x equal the angle. We'll let 90 minus x equal the complement of the angle. Now we're ready to set up our equation. 4 times the complement equals 200. This one's super easy, isn't it? So we don't even have an inequality. We're just ready to go. 360 minus 4x equals 200. I'm going to end up with a minus number, so I'll just live crazy and do it in one step. I could have swam everything around to get positives, but I'm not going to. Minus 4x equals minus 160. Divide by the minus 4s, and we get x equals 40 degrees. Yes, that's right. Okay, so I skipped one that looked a lot like that, and I did one that was even easier. Whatever. All right, 4. This problem is unrelated. 20% of the molybdenum fused. I don't know what molybdenum is. It sounds like some sort of chemical related thing. I don't need to know what it is, and that's why John chooses these really weird, wacky, obtuse examples, is because what he's trying to drive home is the point that the story doesn't matter. Just look for the numbers and the way they're behaving, and you can figure out the math of any kind of story problem. If 1,420 grams did not fuse, what was the total mass of molybdenum used? All right, this is what is called a frickin' formula problem, or fractional parts of a whole, that we learned way back when. If you take a fraction and you multiply it by a total group, you will get a special group. We can also do this with decimals, and we can do it with percents, though we have to put the percent over 100 in order to get the numbers to work. Remember, the of equals the total group, and the is the special group. This helps us relate the numbers, or the words rather, to where the information belongs in our equation. We're using this form down here. Just a second. I have to put a puffy cloud of knowledge around it. This is the one we want to use, and this is the way we're going to understand our problem. This is the original mass of our molybdenum, whatever that is. I might not be pronouncing that correctly. That represents 100%. We subjected it to some sort of chemical process. Some of it fused and some of it didn't. We know that 20% of it did fuse. Okay? That means 80% did not. We can assume there was no third thing that happened. So if 20% fused, then we know that 80% didn't. We also know that the amount that did not fuse was 1,420 grams. What was the total mass of the molybdenum used? So that's this. What was the original amount, the total, right? So this is our total. This is our special group. This is our percentage. We can use this information to solve for X. And we use this formula to do it. 80 over 100, which is another way of writing 80%, times the total group, which is what we don't know, equals the special group, which we do, 1,420. We had to calculate this 80% ourselves. John told us about the amount that did fuse in terms of percent, and then he gave us the gram measurement of the amount that did not fuse. So we had to find out this percentage because we need to have enough information to plug into this. We don't want to mix the two different kinds of information together. All right? That's how we set this up. This is called the frickin' formula because I had a student 15 years ago who could never remember this formula, and in the classic behavior of any young teenage boy, he liked to cuss, or whatever you call using the word frickin'. It's not exactly cussing, but it made him feel edgy and bad. So he always he said, I can never remember that frickin' formula. So we would call it the frickin' formula, and thus the name has stuck. My previous students have contributed a lot of interesting metaphors and nicknames to my teaching, so you'll get to know them. This is Scotty. Okay, so now we're just ready to solve this formula. When we're multiplying times a variable, we usually divide, but when we're multiplying by a fraction, I don't want to divide by a fraction. I don't know about you. So let's use a reciprocal. I could have reduced it first, but I'm not going to. Okay, I'm just going to leave it like that. This all cancels. We've got x by itself. Now I just have to simplify over here. I can see, though, that it would be really easy to simplify this, and I will divide both sides by 20, and I'll get 5 over 4, right? Okay, so that's gone. So now I'm going to divide 4 into 1420. That goes in 3 times. That goes in 5 times. Okay, so it's 355. So this divided by this is 355. And then I still have to multiply that by 5 to get my final answer. We do not use calculators to do any calculations that we can do by hand. We'll use it for trig problems. We'll use it for some log problems. We only use it when we need a specialized function. But for basic calculations, you guys do not use a calculator. It makes your brain lazy, and we don't want that. So do everything by hand, and don't feel like you have to erase it or do it on a separate piece of paper or scratch it out. This is an important part of the problem, so we always leave it. If it bothers you, you can put like a box around it. But honestly, you'll see I just do it kind of to the side, and it's fine. Okay, 25. So what that tells us is that the original weight of the molybdenum, or whatever it was 1,775 grams. If we take this number and multiply it by 0.8, we should get that number. If we take this number and multiply it by 0.2, we should get the amount here, but we can also just do straight subtraction. So I'm going to do 1775 minus the amount that did not fuse, gives us the weight, what did fuse. In the end, I like this diagram to be completely filled out so that we can see the whole scenario of the problem. Even though just this is the answer, and we did get it right, I like to see the diagram completed, so I will always ask you to draw the diagram and fill in all of the percents and amounts for all of the different kinds of our frickin' formula problems, all right? John doesn't necessarily ask you to do that. All right, I want to do one more problem for today, then I'll turn you loose to work on the homework for this. 5. This is one that I work differently than John as well. The ratio of I can never say this word. Pusillanimous, no, that's not right. Pusillanimous brave men to oxymorons on the battlefield is 17-2. Okay, once again, John is using big crazy words and in a context we don't understand to prove his point that we don't need to understand that in order to do the math. What I'm going to do is draw, again, this is something John does not do, a ratio table. They'll always have at least 2 columns and at least 3 rows. This is going to be our ratio information, and this is going to be our actual. I'll write it out this time, but normally I just put R and A because life is short. Okay, the ratio of pusillanimous brave men, so I'm just going to put P, brave men on the field to oxymorons, I'm just going to put an O, is 17-2. I don't need to know what he's talking about, it's fine. If the total of both on the battlefield is 342, okay, so this is my total row. So he gives me information about the ratio of one to the other, but then he says the total number on the battlefield is 342, and now he wants to know how many are oxymorons. So that's where I put my X. This style of problem requires us to fill in this ratio problem by just adding together, right? We can do that, that's easy. Now we've got at least one row that has all the data, and we've got another row that has the desired information in it. We get to ignore the top row. I always gently exit out so I don't confuse myself, but I can also see it if I accidentally cross out the wrong bit, all right? So again, no erasing, just cross out what you don't need. What we're gonna do is use these 2 rows of information to create a proportion. And the genius of this table is that it has all the numbers arranged exactly the way we want them for our proportion. And we can just lift off the 4 symbols and put them into this format, and we're great to go. So now we just have to solve. Cross multiply. 2 times 342 equals 19x, right? Cross multiplying. And now I'm going to divide away the 19. I'm not going to multiply this yet because I would rather make my numbers smaller than bigger. I make them smaller before I make them bigger. So I don't want to multiply this up because I might find that there's dividable numbers here. And I'll tell you what, John always makes it come out nice. Always. He's such a buddy and a pal. So I'm going to look and see if 342 will divide cleanly by 19. All right. Does 19 go into 3? No. Does 19 go into 34? Yes. It goes in just once, right? I subtract 15. 2. Now I have to figure out how many times 19 goes into 152. Well, here's my best clue. I know that 9 times something, I want it to end in 2, and so that would be 8. So let's just see if that works. 8 times 9 is 72. There's the 2 I wanted. Carry the 7. 8 times 1 is 8 plus 7. Look, it worked out, right? So what I did was I looked at my ending digit and said, what times this number will give me that ending digit? And then that's how I decided what to try. I'm done. So this now, this goes into this, and it becomes 2 times 18 equals x. And so I get x equals 36. Yay. That's what I wanted. 36 oxymorons. I should write that. Okay, so this is the method I use for solving any kind of ratio problem, and it is a fantastic organizer that helps you visualize the problem and then move into the equation with a minimum of fuss and bother. Okay, I just worked us through the first, well, I skipped number 2, but I did 1, 3, 4, and 5 of your problem set. That should help you get started. Remember that the solutions manual can help you with any problems in your homework that you're stuck on. Talk to each other, talk to me. Good luck. Remember that you're going to do, let me just flip this over and write one more thing. You're going to have 4 days of homework this week. Here's a little chart for us, right? So right now, this is day 1. Maybe it's Monday, maybe it's not. What I want you to do is to do lesson 1, the odds. Okay? Then for your second day's homework, you won't watch another video. You'll still have lesson 1, but this time you'll do the evens. Right? And then on day 3, which would be Wednesday is the way I look at that, right? This would be maybe Monday, maybe Tuesday. You may be on a slightly different schedule. On Wednesday, I'll drop you the link for lesson 2. And then you'll do the odds. And then your 4th day of homework for the week, you'll do lesson 2, the evens. Okay? We're not doing any concept review problems. Just a second. No concept review. And like I said, John very kindly labels them clearly in the homework. They're always at the end. I'll show you again. No, we're not doing those. All right? So you just can thank me for that when you get to the end of your homework and go, oh yeah, right. So lesson 1, odds, and then the evens. Thank you for your patience. Goodbye.